Thank you very much, Dr. Srivastava. So from here we go on to the next session of the day, Space-Enabled Land Warfare Enhancing Army Operations. This session delves into the critical role of space technology as a force multiplier for land operations in modern warfare. Participants will explore advanced space-based applications that enhance Army capabilities, including satellite-driven intelligence, high-precision geolocation for navigation and targeting, and secure communications framework. The discussion will also cover real-time data relay systems that support situational awareness and decision-making on the battlefield. By integrating these space capabilities, land forces can achieve greater operational effectiveness and maintain a strategic edge in complex combat environment. For the same, I would like to call upon the chair and the moderator, Lieutenant General Dushyant Singh, DG Clause. And the panelists, Major General Dr. Sandeep Sharma, VSM PhD, former scientist, NTRO. Colonel Harinderjit Singh, Director, Imagery Analysis and Geospatial Intelligence, DIPAC. Brigadier G. Manoj, Defence Space Agency. Wing Commander PRL Prakash, Vice President, Aventel Limited. And Lieutenant Colonel Christopher McIntosh, CEO, Methera Global. Over to you, Chair.
Thank you, and thanks, SIA, for giving us this opportunity to conduct this session to Clause, the knowledge partner of this particular event. I would like to also thank General Pannu and Mr. Prakash and the President SIA for giving us this opportunity. Since the session post-lunch has been about chits and calls, I think I have also got a chit and a call to reduce this session by about 10 to 15 minutes. So I'll request my panelists as well to kindly structure their opening remarks to about 5 to 6 minutes only. I would recommend that you give out the challenges and the recommendations. I think rather than giving out information, which this particular seminar over a period of last 2 days has actually covered most of the issues. So before I hand over the the mics to our panelists, I would like to only cover 2 things, since I am also a practitioner of warfare, so I should not go without saying something about warfare. First of all, 3 points only. First of all, warfare is something which is as old as the humanity. But what is important is there is a relationship which is between humanity and technology. So and technology has been both friends and enemies, in the sense it has been used for peaceful purposes as well as for warfare. So we are seeing the same kind of a phenomena right from age-old history. What is important is the inflection points. There are 2 major inflection points which have taken place, and the first one was the Industrial Revolution. The second was the advent of nuclear energy. That changed the entire course of warfare. And the third one which we are witnessing is the advent of digital technologies, which has been actually propelled into a much more larger phenomena or paradigm because of the artificial intelligence in space. Space has almost collapsed the various domains of warfare, which is starting from space down to land, air, and maritime. So we are seeing now a multi-domain operations which are taking place, and the key drivers for that are space, communication, and artificial intelligence. So therefore, the focus of this particular talk is going to be on that. I had few slides. I'm not going to show them, but what I want to tell you is that we are a laggard as far as space domain is concerned. India needs to, should I say, buckle up and take the driver's seat in this. We are way behind as far as the other major powers are concerned. We have just 3 military satellites, and we have the others which are dual use, which takes it to about 89 satellites. But बोलते हैं कि दिल को बहलाने के लिए गाली भी एक ख्याल अच्छा है. With that, I will first call upon our online discussant, who is Chris. Chris, kindly keep your talk to as brief as possible, but I would like you to cover something about the MEO, because that is something which we have not spoken about. We have spoken about geo satellites, and we have spoken about LEO. But what about MEO? And I believe you have an expertise on that. Over to you, Chris.
Thank you. Firstly, I'd like to explain why space is so important and why things are changing. The main thing that's happened is that space and cyber have become components in their own right, supporting the land, the maritime and the air components, and we're at a stage now where space is critical. I use the word critical because trying to imagine fighting without space is extremely difficult. And some of our potential adversaries would prefer to deny space to us, to allow us to diminish and reduce the effectiveness of our land, air and maritime components. Therefore, in the UK, we look at space and cyber as being a separate component, but we see it as being a fundamental component. Now, the reason why I focus on MEO, medium Earth orbit, similar height to GPS, i.e. around 20,000 kilometres, is because it's ideally placed to allow us to provide broadband services anywhere in the globe at any time. So instead of being constrained to where the delivery of communications can actually occur, MEO, similar to the way GPS operates, allows us to be able to focus our energy and communications anywhere at any time. Instead of trying to provide a layer of communications around the whole Earth continuously, we can focus our communications where we need them. But communications is not the only thing why we need broadband and we need services to support the land operation. We all know what's happening with the use of PNT, positioning, navigation and timing, and it's increasing so much that we do not even realise how dependent we are on the services. And without PNT, without the services that are delivered from space, often invisible to the end users, lots of our systems, such as artillery, will not even be able to operate. Therefore, especially from a UK perspective, we look at space domain awareness as being essential, i.e. the ability for us to be able to defend our assets in space. That's from physical attack, from electronic attack, but also from denial of services. And that means that we must rely on dual use services as well as national hardened systems. MEO sat between the LEO and the growth of satellites, and GEO, where our hardened, expensive military satellites sit, is ideally positioned to do the ISR battle of collecting intelligence, surveillance and reconnaissance of what's happening in space, which has a direct effect on the land components battle. That's all I want to say at this stage.
Thank you, Krish. We will take the questions, so be online for as we finish with the other speakers. I will now call upon Brigadier Manoj to speak on the role of DSA, PNT and ISR. I will again request you to keep it brief. Look at the challenges which we are facing today and what do we expect from the industry. That would be that should be the focus.
Can you hear me?
Yeah.
So thanks a lot, sir. Like you said, I'll skip through a lot of my prepared slides. We all know about the trends in warfare. All I want to highlight is that as the lines blur, the use of commercial and military, the lines between commercial and military are blurring. It's been brought about very, very effectively by Mr. Elon Musk during the Ukraine war. Therefore, space warfare is probably the forerunner as far as the trends in warfare is concerned. And with its characteristics of global reach, persistence, there's a pervasive dependence of the armed forces on space. Like Chris before us said, it's one of the components now of warfare. And the side which has space on its side will have the decisive military asymmetry. And typically when we speak, with the dependence come the threats in space also. So I'll not talk too much of that. Therefore, typically when you describe the military space mission areas, we need space for defense, that is to enable our armed forces, and we also need defense of our space assets. So typically these are the 5 space-based services for the military: ISR, PNT, SATCOM, SSA and countermeasures. I'll highlight these in a bit more. So the first 3 elements are what we say as space for defense, and the last 2 elements are critical for the defense of space. The US has defined 4 space mission areas as highlighted: space support, force enhancement, space control and force application. So for the force application, even they said these are potential missions of the future, that is attacking objects on Earth from space. So we don't talk about it in the military parlance too much. So where does Defense Space Agency fit in? I take your mind to these 2 parts: force enhancement and space control. So there are 2 verticals which are looking at force enhancement, that is provision of ISR, PNT and SATCOM. Also there is one which is looking at defense of our space assets. Then we have a directorate of R&D and quick reaction mechanism. It also carries out the interaction with, primarily interaction with industry. And then we have our own administration and ADAM. So this is how we are organized, just for your reference. As far as the space-based services for military concerned, I will now talk upon these aspects. I am not concentrating on the Army land operations only, being from the Tri-Services Organization. So ISR, it's always been the high ground. Initially we had forts, then we went up aircrafts. This was the first satellite imagery taken by US Explorer 6. And this is now the very famous photograph just prior to the invasion. So apart from this was again we had someone from the Planet highlighting few use cases. So just focus on this area rounded. This was this image was on 22nd May 2020, and by June 20, that is about a month later, you can see the Chinese troops build up in that area. So this was discerned by the satellite imagery. Another use case, this is near Mariupol. Look at the area which is circled. This is as of 23rd of March. And by in about 10 days time, this was claimed as mass graves dug by the Russian forces, pointing to their war crimes. So it's been very effectively utilized for perception management also. PNT, we are all aware of which all systems are there. So we are one of the select few who have our constellation up there. Functioning principle to this learned audience, I would not go into much details, but what I want to is to describe the basic architecture of NAVIC. NAVIC is the navigation through Indian constellation, regional system of 1500 kilometers beyond the Indian borders. constellation of 7 satellites. 10 satellites have been launched till date from IRNSS-1 Alpha to NVS-01. And there are 2 different kinds of services. One is the standard positioning service, which is available for everyone to use. And then we have the restricted services, which are available only for the armed forces and the authorized users. There are issues in the some of the satellites, but we are getting there. Our capabilities would soon be established. And what are we looking at in the future? So all sorts of platforms that we can think of, we would definitely want to integrate it with NAVIC. As of now, we would have it NAVIC also, apart from GPS. And as the time comes, we would have it primarily NAVIC with GPS also later. Satellite communications, like General Dushyant said, we have 3 SATCOM satellite communication satellites exclusively. GSAT 7, which was a Navy satellite, 7 Alpha, and GSAT 6, which is a S-band satellite. It's not a defense satellite per se, but the anchor users are defense. We have large number of plans coming up. So what are we looking at? Like someone just before me also said, all the technologies in space are dual use. So we need to focus on all these dual use technologies with the intersatellite links, edge computing. These are just few of them mentioned. The list is endless. There are a lot of you sitting who would know much more than me on that. So because of paucity of time, I would just like to end with this thought. Let's make that incredible be known. Thank you so much.
Thank you, Manoj. I'll now request Mr. Prakash to kindly elaborate on the industry aspects of how they can supplement land warfare. So over to you.
Thank you, Chair. And am I audible? Yeah. So firstly, I want to brief you where I'm coming from. I'm coming from a company called Avantel. It has an existence of over 3.5 decades, 35 years. And almost last 2 decades plus, we are rolling out the ground segment solutions, especially the user terminals. Till date, we have supplied approximately around 30,000 plus terminals for various applications. Right from the ship, to the submarine, to the man-pack, to the railways. We have supplied around close to 6,300 terminals, which are now operating on various locomotives, and the railway run-through information is on live transported to the central control center at Delhi. And we are in the process of supplying another 1,800, and another 12,000 terminals are being supplied. Similar, another application, something connected which we have done was we are supplying around 30,000 terminals to the fisheries, basically for maritime awareness, domain awareness. Now, having such large experience of SATCOM, and mind you, we were the first one to roll out the airborne SATCOM in India after going through the entire cycle of CEMILAC certification process. So our airborne solutions are operating on all naval aircraft, and we have also supplied to Boeing P-8, and now currently our MSS system is getting integrated on MH-60 Romeo. We have directly supplied to Lockheed Martin, and it is coming as a factory fit item as part of the helicopter. Another good news I wanted to share today is on the terrestrial front, we have already done an SDR which is compliant to SIA 4.1 architecture. We have already done demonstration trials as part of one RFP, and we have been technically through. And earlier we have supplied around 125 systems of 1 kilowatt HF transceiver to Navy, wherein we bought radio and modem from Hagneck Communications from Germany. in record time of, still the warranty is on, we are facing some problem from on the service issues. So we have in record time developed the entire radio and modem ourselves. We have replaced it, and we have successfully, last week we have approved for the Navy. So almost the entire system is fully indigenous IDDM. This company rolls out the solutions fully indigenously. We spend around 15% of R&D budgets year on year, and solutions are either import replacements or direct indigenous technology. Now coming to the theme of the session, basically on the SATCOM side, being coming from the industry, I have a few quick points to make. Is basically, if you take the army operations, SATCOM has to be there from the soldier to the higher formation. But there is a varied requirement. Means a dismounted soldier who is on the toes, he needs SATCOM connectivity, not a data, because he's fighting. He needs a voice call. So he needs to have, I'll connect this with another concept of thing. So he needs only voice. Maybe a little very low data application or 300 BPS is also to send in emergency images. The next level is COTM and COTP. Communication on the move and communication on the pause, which will be a vehicle-based system or a man-carried system. That will be the next level, wherein data will be little high, but voice is again important. But when you go into the higher formation, like at a company level or a brigade level or the command headquarter level, there you need more data, means high data rates than voice, because these are all backhaul communications and in the hinterland of India. So you have all various other means of communication. So you actually only data is more efficient there. So there is something called connected soldier concept, wherein when he is moving, mind you, it is okay in the peacetime. We are saying, I have taken a SATCOM. My satellite is having a footprint of India. I have a SATCOM capability. But what when unfortunately if the flag goes up and I need to do operations deep into the enemy territory, then only SATCOM is the option. Then the soldier needs to have connectivity at all times. There lies a problem here. Before stating the problem, I'll tell you is yesterday when Viasat official was mentioning, he said that it should be a mix of commercial satellites plus Indian satellites. I agree with him, but up to some extent. Why? Because yes, commercial satellite we can use, but when the hostilities are there, we have to depend on indigenous satellites. So when indigenous satellite comes, you need to develop the entire spectrum. The user segment should be ours. In till the satellite, it should be ours. Okay. So even for the foreign satellites, also user terminals development should be under our control. So that is one more point I wanted to make. Now comes the bands of operation. Actually, if you understand the satellite communication, it's right from UHF to Ka band, and now it is going to U and V band. UHF is basically a very low data rate, best for voice. Now comes the S, which is low, some data rate, voice. When you go up the scale, KU, Ka and all, it is high data rates. Voice is voice over IP and all those things, but still it has to be a high data rate. So most important is for the beyond line of sight communications, you have to have UHF SATCOM connectivity, or if you have an S-band satellite or a KU-band satellite, you have to have a steerable beams, because when the flag is up, you need to have a footprint where my operations are happening. So we need to plan. As a planners have to plan this concept. Now, I've been, actually, there is something called a civil industry fusion. Being from the industry, satellite and the user segment is tightly coupled. You say that, okay, I have launched a satellite, and once the satellite is operational, the user segment, now you want to ask for design and development of user terminal, that doesn't happen. Actually, when the satellite is being planned, the requirements has to be told to the industry, maybe through some open houses and all. Maybe you can take 2-3 people on board and develop the solutions. that is one aspect of civil industry fusion, wherein we request the planners, especially the Army planners, to involve us from start. And mind you, we have full indigenous capabilities. Entire thing is being done in-house. If you have state as a problem statement, we will be able to develop and provide you solutions. We already have 5 IDEX challenges, wherein we have developing a convoy management system for the Indian Army, broadcast receiver from the Indian Army, and a small mobile all on the S-band segment. And we are also developing 2 K-band solutions for the Navy. One is based on the phased array antenna. One is for the portable solution, and one is for the airborne requirement. So these are the initiatives which we are doing. So I request the planners, if some requirement on problem statement is thrown upon us, we will definitely able to help. And maybe it will be a little gestation period, but why I brought that example of 1.5 year, if you can have developed the SDR fully compliant to SIA 4.1, we can develop as per your requirement the SATCOM user terminals, including antennas. Okay. Last but not the least, actually we were also the competitor for this orbital slot of in-space thing. Unfortunately, we could not get it, but we are continuing the process. We are now trying to get an orbital slot for ourselves, make a satellite specifically for strategic use, because we know the strategic segment well, and launch a KU Ka-band satellite, and we'll come up with the proposal in due course of time. So that's my submission, sir.
Yeah, thank you, Prakash. You raised 2-3 issues about involvement of the Army in the development process. I think that is that moment is already taking place. We are creating interfaces. One was referred to by Jan Brar as well, and even at the Army headquarters level, there are this kind of moves taking place. Of course, it may not be directly with a particular industry. I mean, that route is something which every industry person wants, that I should be directly linking with it. But we are creating these research centers which will possibly then incorporate the industry reps also in their research and development process. The second issue which you brought out about was, the satellites are the only means which can provide communications across the borders when we are actually out of our terrestrial communication links. But given our limited assets which are there up in the highest battleground, I think we need some alternative solutions till we reach that level where we can say पूरी तरह से स्वावलंबन हो गए हैं. आजकल आत्मनिर्भर भारत को थोड़ा सा बदल दिया गया है. We are now talking of स्वावलंबन भारत, which means that the right from development to design, everything is with us. So with that, now I'll request Harinder do take on the remote sensing, image interpretation, etc. But what is your forte? Again, I'll request you to just give out your challenges which are there, and then what do you expect from the audience here? Because the audience here is mostly industry. So, your target, time over target, etc., those issues must be highlighted. Yes.
Okay, good afternoon. Till such time the slides are being uploaded. Having been in the field of imagery intelligence and geospatial intelligence for last about 20 years, I will develop on how remote sensing is shaping the battlefield now. Geospatial int is not only reshaping traditional land warfare, but also enabling space-enabled land warfare, where data from satellites directly informs, supports, and enhances ground operations. By providing real-time intelligence, precise targeting, and global situational awareness, remote sensing and satellite imagery are now indispensable tools in achieving dominance in land warfare. This enables commanders to have well-informed decision-making. Okay, remote sensing. As everyone is aware, DIPAC, we are having three series of satellites. One is the EO, basically the Cartosat series. Next is the SAR series of satellite, which we call the RISAT series. And third is the hyperspectral satellite. For actionable intelligence, what we require is a high-resolution data along with frequent revisits so that the basic requirements of targeting can be met. Satellite imagery is most important tool in making the imagery intelligence, and this is what is being achieved through imagery intelligence reports. Basically, the wide coverage of strategic and depth areas, terrain analysis, target recognition, infrastructure monitoring, 3D models of target areas, visibility analysis and dead zones, assess logistical capabilities and limitations of the adversary, route assessment and planning, choke point, navigational assistance, logistic planning, precise targeting. Precise targeting, what is important is all the 3 X, Y, and Z planes. This is being achieved through the very accurate base layer. Change direction and battle damage assessment, a lot has been said about that, so I did not dwell upon that. And this is being achieved through high-resolution EO sensors. The modern satellites, such as those in the military and the civil domain, have now offer sub-meter resolution 25 centimeters and beyond, enabling the detection of minute details like movement of troops also. Synthetic aperture radar, it allows the satellites to capture images through cloud cover and at night time. This capability is particularly useful during adverse weather conditions, especially during rainy season and the snowfall. However, for small size army targets, detection is possible, though the identification is not possible. Hyperspectral imagery uses the available advantages of both VNIR and SWIR bands, and we are in the process of identifying the material used in enemy infra development and types of equipment. Fusion of SAR and EO imagery. This is a new technology being used, which will help us in looking at objects which are under cloud cover, camouflage, as well as at night time, which will help us to remove the limitations of both the EO and the SAR satellites. Challenges in space-based ISR for land warfare. Satellite constellation. In the current scenario with the limited available resources, the satisfaction level presently is barely adequate. The shortfall in the requirement at present is being met through commercial resources. In the current scenario, what we need to do is we need to employ all the available resources, that is UAV, ground sensors for the tactical depths, and satellite imagery should be used for operational and strategic depths. However, as we move forward and with the planned induction of new resources, we will be able to increase the availability of data, and the real-time monitoring of the desired targets will be possible. Latency and timelines. Delays in acquiring, processing of satellite data and dissemination of geospatial int can reduce its relevance in fast-paced combat scenarios. With the automated processing of data and the use of AI tools, these are being overcome. The geospatial int generated daily is being shared with the decision makers through the available terrestrial and satellite networks. Availability of data. With the availability of future satellites in inclined orbits, in addition to the SSPO, the transparency in battlefield can be ensured with persistent coverage. Data overload. With the planned induction of more satellites in future, the sheer volume of data generated by the satellites can overwhelm processing and analysis capabilities, necessitating use of AI to assist the imagery analysts. Now, technological advancements which we are looking at. First is the high-resolution base layer for accurate targeting, AI for onboard data processing and decision-making, big data analysis for real-time insights from vast data sets which will be available in future, quantum technology for efficient processing and secure data transmission, multi-sensor data fusion to include satellite and other space-based airborne platforms like UAV. AI-powered data analytics. With the availability of huge data, AI models are being used for target detection and identification to assist the image analysts. Presently, the work is in advanced stage. To conclude, remote sensing and satellite imagery have become indispensable components of space-enabled land warfare, empowering armies to operate with greater precision, awareness, and effectiveness. This is now helping the commanders to approach the land-based conflicts well-informed and adequately prepared.
Thank you, Harinder. You have put up a demand which is very, very futuristic. AI for data processing, of course, it is going on, but quantum technology, I think that is something which is still in the future. It will take some more time for us to integrate and fuse what we are getting. But I would like to share here as to how much lagging we are. You know, there was an exercise conducted by the United States AUKUS group, Australia, United States, and UK. So this was done in South Australia, 2,000 square kilometer of an area. Autonomous vehicles, autonomous weapon systems were moving in this entire area on their own, and they were taking the use of satellites, etc., also other terrestrial links to carry out their maneuver. And there were a group of scientists which were trying to disable their activities. And you will be surprised that the outcome of the exercise, this is last year, 2023, more or less the exercise was a success. Of course, when you have a controlled environment, normally the scientists would ensure that they achieve success, but that notwithstanding, that's the way people are going ahead. And I think we are still in a very, very nascent stage of land warfare, how it can be augmented by space-based and AI-based and cyber, etc. technology. So with that small little brief, because why I mentioned cyber is that we have to my right a cyber expert, General Sandeep Sharma, from former NTRO personnel, and who had a long, almost 6-7 years of experience there. Over to you, Sandeep. Do cover issues that will enable Army to undertake operations on the land.
Thank you, Dushant. This is a very typical multi-domain operation. The slides are being shown toward my back. The mic is on my right. The clock is in front of me, showing we are well past that panel discussion, but I'll still take on, and I'll start with few statistics. I was going through Times of India today. I don't know how many of you read.
We are well on time. Do you take your time, 5-6 minutes?
No, I'll be shorter than that. Times of India, the center page. See the statistics. India's satellite constellation is the 7th largest in the world. Highest is USA's 8530, followed by Russia 1545. The difference between the two countries. China 724, UK 658, Japan 208. Next is France at 105, and India also at 105, but placed below France. This is today's Times of India. And then I went to the net. There is a data published by Union of Concerned Scientists, US organization, which is widely accepted for data on satellite. The last update is of 2023. And from 2023, okay, is it okay? Yeah, 2023, it talks about 7,560 satellites, whereas the today's data is of 14,000 satellites. In 2 years, the figure has doubled. And it mentions that an estimated 77% are in LEO, further 15% are in GEO, and 4% are only in MEO. And of the total number of satellites, 15% have military or dual-use purposes. So it is not that it is going berserk. It is only 15%. The rest are being used for civil/commercial usage. Just over half of those, of the military satellites, they are in LEO. The combination of low altitude and a shorter orbital period makes LEO very suitable for military applications. And I will not go into further statistics because there is no time. It's very interesting statistics. I'll straight away come to few space-based applications. My life has been made easier by the speakers earlier because I'll not speak about. Let me go from the classification point of view. Let's start with satellite-driven intelligence. IMINT has been very deeply covered by the two speakers before me, and they help military operations in a big way in targeting battle damage assessment and situational awareness. Next is the second, both comment as well as ILINT, or we call it as non-comment. And they help to a large extent in operations. Then we have high precision application for force enhancement in terms of precision navigation and timing, precision strikes, precision timings, and enhanced situational awareness by providing battlefield awareness. I'll just touch upon some advanced space-based sensors. The rep from DIPAC spoke about hyperspectral sensors. It's a technology which needs to be taken note of. It's a chemical fingerprinting of the objects on the Earth. IIT Mumbai has a very good lab on hyperspectral imaging. There are hyperspectral satellites which have gone up by many countries. Many, when I say many, means it's only 5, 6. Then SAR, of course, has been spoken. It is required for defense forces because of its day and night coverage. And I would like to bring out here that we need an AI model to convert SAR into EU, because that's the easiest one for people to interpret. And there are models where people are working on it. And space-based radar, these are satellite-based radar system in US military space-based surveillance system, SBSS. Uses satellites to detect and track enemy satellites, missiles, and aircraft. You must have read in the newspaper about 3 years back, the government of India has also given clearance to our SBS-3. Rest is communication and networking. SATCOM has been adequately covered. I'll cover on the tactical part of it. Wing Commander Prakash spoke about the need for a soldier to carry that mobile where he can speak. It's primarily called GMPCS, Global Mobile Personal Communication through Satellite. We'll remove the word global, it should be for the Indian scenario. So we have the players Thraya, banned in India. Thraya 3 failed, 4 was launched on January 4th, and it has moved from C-band global coverage to Ka-band. Then we have Inmarsat or ISAT and Iridium. So such type of personal mobile communication system through satellites are required for the battlefield systems. Otherwise, the ComSat as such is basically not a B2C, it's a B2B concept. And it becomes very difficult for a soldier to carry that bulky equipment. It's okay with the headquarters, not for an individual soldier. Of course, satellites are useful in logistics and supply chain management, cyber and EW. I'll not speak much about these two. And some advanced applications like space-based weather forecasting, space-based Earth observation, and autonomous systems. I'll just speak about use of satellites for TechInt capabilities. The global geopolitics, TechInt has emerged as a critical component of national security. So satellites play a vital role in this endeavor, offering unparalleled advantages in terms of surveillance, communication, and data collection. One of the primary advantages of satellites for TechInt is their ability to provide high-resolution imagery and SIGINT. India program already been covered, RISAT and Cartosat, so I'll not delve into details. I'll come into straight away the problems for us, or as far as the forces are concerned, what are the aspects to be taken into consideration. Firstly is remote sensing satellites for surveillance should have a revisit capability to meet the operational data update needs. That is very important. You don't want a revisit which takes place after days, because when the war takes place, it has to be very quick. And next is all-weather imaging capabilities to cater for coverage during day and night. This will require radar satellites. Thirdly, high resolution, I call it submetric. Sensors with ability to provide very high resolution data during operations. These are the 3 important things which needs to be taken into account. Despite these advantages which the space or satellite gives you, The use of satellites for tech capabilities has serious challenges, and one of the primary concerns is the vulnerability of satellites to enemy attack or disruption. There are space weapons, that's a talk by itself, whether it is Earth to space, space to space, and space to Earth. These are also part of the warfare. We will not touch upon that because of shortage of time, but we need to take into consideration all these things, and the increasing congestion of Earth's orbit and the growing risk of space debris poses significant challenges to India's satellite program. I'll finish with that.
Thank you, Sandeep. I know you are restricted by your previous appointment for not sharing certain things. I think we have to bear with that. But what I would like you to just quickly tell me, or tell the audience also, as to, you see, what are we doing at the level, at the apex level, to ensure that the OODA loop is shortened? Because nowadays we are adding OOSDA loop, that is, observe, orient, share, decide, and then destroy, or whatever it is. So act. So this is an area which has been found wanting. So from your previous organization side, anything being done to shorten this loop as far as India is concerned? Today in Ukraine, the fires are taking place within 3 to 4 minutes, which used to take about 40 to 50 minutes to get fires on target. So this is something which I think you should throw some light on.
Primarily it boils down to the sharing part of it.
That's all.
That's all. So
asking about the sharing, because that's the thing which is preventing multi-domain warfare.
I understand, because it also involves processing. Yes. So processing is okay with the forces, but the sharing becomes an issue. Yes. There are challenges. Come back to this. I'll cover 2-3 challenges. Firstly, the technical challenge in this is the interoperability. Different satellite systems and sensors have varying data formats, so making it challenging to share and integrate intelligence. Next is communication network limitations. We have limited bandwidth. They can support me in terms of the size of the image which is there, and it takes time to transfer these images.
1.5 GB minimum.
Firstly, you have to process it, then you have to transmit it. And
is about 16 GB.
Absolutely. And type of bandwidth which is available on the network, the network which is there with us has severe limitations, severe limitations. And then finally is the data management and storage. It's a big data analytics which has to be carried out, and there is no common platform to do that. So each services in their own silo do that, and which become difficult to which are the hindrance to a shortening of OODA loop. Then we have the organizational and structural challenges also. Each service has its own ethos, which is difficult, and where the role of now the IDS or DSA.
Okay. So basically, thanks, General Sandeep. We have a very limited time. One last question to Chris, because that is something which is bugging everybody. Chris, are you there online or? Yeah. So Chris, I want you to highlight, you know, when the data was shared about the number of satellites in the LEO and number of satellites in the GEO, the least is in MEO. Why? What are the challenges of MEO? You gave some tremendous advantages of MEO satellites. So what is the problem? What are the challenges, and why there is not much of a traffic? In any case, we want to avoid debris. So the debris would be least, I suppose, in the MEO. So from a layman's perspective, I am talking about. Could you throw some light on that, Chris?
Yeah, certainly. Historically, there were issues with MEO. When you look back to the GPS satellites, the early GPS satellites that went up to close to 20,000 kilometers, they were like armored tanks. And that was because of the radiation hazards that are particular to MEO. That meant that the satellites used to be heavy, they used to be expensive, and their lifetime was reduced. But what's happened relatively recently is that new methods to protect satellites against radiation hazards have been invented and are being trialled on GPS satellites and other satellites. So the cost of actually putting satellites into MEO has reduced significantly. That's number one. Number two, launch, which was predominantly designed for getting satellites to GEO, and then changed to getting satellites to LEO, meant that MEO was a difficult altitude to get to. And you paid twice, if not 3 times the amount to go to MEO than you did to go to GEO. Now, what's happened is companies around people like Elon Musk are now looking at different types of delivery systems, reusable systems, which in essence allow them to stop off at MEO on their way to GEO, or put on missions that will deliver satellites to different parts of MEO on different altitudes and different inclinations. So again, that second problem associated with cost with MEO is now reducing significantly. And then the third one was the requirement for terminals on the ground that could track MEOs as they move slowly through space. And of course, as we've all seen, there's been a huge increase in the amount of research and development for terminals and antennas that can track fast-moving satellites, i.e. LEOs, which means now the terminals and the antennas for MEOs, again, have reduced significantly in cost. So most of the problems associated with getting to MEO have now been solved. And we're at the stage now where companies, organisations are planning on putting more satellites into MEO because of the fact that those barriers to entry have now been reduced significantly. And from my perspective, I find it really interesting that so many people have been in the space industry for so long. That means they remember the problems associated with MEO and have not moved on to look at what's changing and what the real cost associated with MEO are. And at Mevera, we believe that the disadvantages associated with MEO are far less than the advantages you have of the freedom of action, freedom of movement, and the fact that you can service any point on the Earth cheaply and quickly, and also the fact that the threats from space are now so huge that being able to observe, collect data, intelligence and information from moving satellites on different inclinations, looking at areas, some of which we have not even identified as being problem areas, is what makes Mevera unique.
Thank you, Chris. Final time. So I really don't have even time for asking questions. But at the cost of, again, annoying the organizers, I am also part of it. So I can take that annoyance. Quick 3 questions, and then we'll wind up this session, if there are any. I know, yeah.
I have 2 questions. One is regarding the data standard. Second is about data fusion.
Okay.
Standards. Russia fired almost 150 missiles, thanks to NATO, not Ukraine. And the STANAG, the standards of all the sensors, starting from AWACS down to the ground sensors, and the shooters were common, and the missiles could be taken out. In India, what are we doing, and we should be doing, so that data standards are common? Second is data fusion. We have the 3 Army Navy AFOs. Data are different, sensors are different. We have NTRO, DIA, NIA, DIPAC, whole lot of raw. From ARC we're getting data. We must compile them, get them collated, after that curated, store in data lake, and whoever requires, the final intelligence should come to him along with the predictive and prescriptive analysis. What are we doing about this? Thank you.
Okay. Any other person? Any question? 2 years already asked, so I'm left with only 1. Okay, I think we really don't have time. DSA, could you take on this? I mean, minus the information which you can't, but you can give him a general idea if we are on that path or we are not on that path.
Sir, definitely we are on that path. I'm talking of the second part of your question, the data fusion, the intelligence reports generated by the various agencies, not just the satellite or imagery, this thing, intelligence, but also open source and LNT, even human. It is work in progress, sir. The first thing is already live with the various agencies. So people are getting now a fused picture. There is a strategic agency which is heading that platform, and it is being shared across all the strategic agencies.
Yeah, I think I'm also part of this kind of initiative which is going on. So there is work going on, but of course we have our own limitations. It takes time for such things to finally materialize. With that, we'll come to the end of our session. I would share just one more information for all of you so that we know where we have to go. US has launched this year itself, last year, I mean, it's 2025 now. In 2024, they launched 6 satellites in LEO. And the capability on 2 of them is to detect hypersonic missiles at the point when they are being launched, because if the hypersonic missiles get launched finally, I mean, once they are up in the air, you will get, the best of the navies are getting about 14 seconds to react. And that's too much of a time, too less of a time to actually counter hypersonic missiles. And that's why you heard Putin say that there is no response to hypersonic missiles. So I think we need to be looking at that. Our adversary, you all are aware what kind of a capability he has. With that, thank you panel, thank you the participant. Despite me standing between the tea and you all have been a patient listeners. Namaskar, Jai Hind.
Thank you so much for an insightful session. We'll have a group picture.